Hi everyone, we are from Group 5. We will presenting MRI as our selected biomedical device. I'm Yi Xuan and my group member are Woon An, Fatimato and Yun Ting. Now, I will talk about magnetic resonance imaging (MRI). MRI is a medical imaging technique that uses strong magnetic field and radio wave to generate detailed image of the inside of the body. These images help doctors diagnose a wide range of conditions and disease, including problems with the brain, spinal cord, internal organs, and soft tissue. Next, I will talk about how the MRI machine works. First, the MRI machine uses large cylindrical electromagnets to generate a strong magnetic field. This field aligns the protons in hydrogen atoms, mainly found in water molecules in the body, along its direction. In this experiment, we use the magnet to produce the strong magnetic field, and the needle of the compass is act as the hydrogen nuclide. The proton alignment is under the influence of the magnetic field. The protons align either with or against the field. Slightly more protons align with the field, creating a small net magnetic effect. After that, a pulse of radio frequency energy is sent into the body. These RF pulses excite the aligned protons, causing them to absorb energy and flip out of alignment and then into a higher energy state. In this experiment, we will use the coil with signal generator. Then, when the RF pulse is turned off, the protons begin to relax back to their original aligned state. Then they will release the absorbed energy. In the MRI machine, it will detect the released energy. The MRI scanner detects the energy signal released by the relaxing protons. Different tissues release energy at different rates and then produce unique signals. A computer processes these signals to create detailed cross-sectional image of the body. The differences in the relaxation time between tissue result in high contrast and highly detailed images.
The concept of our experiment, where a compass needle acts as hydrogen nuclide, a magnet stimulates the static field, and a coil with signal generator represent the RF pulse. When the signal matches the needle resonance, it oscillates like nuclear in MRI, turning off the signal and removing the magnet, causing the oscillation to decay, stimulating relation and energy emission. The theory of our experiment, the setup used key electromagnetic principle, Faraday's law, where we changing magnetic field from the coil-induced current, Lenz's law, where we induce current oppose the change in magnetic flux, resonance, max energy transfer when signal match needle, natural frequency like MRI at the Lemmer frequency, and needle slowing down showing damping and signal decay similar to MRI relation.
For the demonstration part, we will need to prepare a few types of materials, which are the compass, lithium-ion battery, crocodile clip, strong magnet, copper coil, copper wire coil, breadboard, Arduino Maker Uno, resistors, jumper wires, and N-channel MOSFET. Next, we will need to connect all the components into a circuit as shown in the diagram, and then we can move on to the demonstration. The needle of the compass represents the alignment of hydrogen nuclei with the magnetic field. Bring the magnet near to the compass from one side to align with the compass needle. The needle will point to the direction of the magnet. This mimics the static magnetic field used in MRI to align nuclear spins. Next, turn on the signal generator circuit to generate an AC current with a frequency around 5 to 30 Hz to match the mechanical resonance range of the compass needle. Adjust the position and distance of the magnet from the compass while keeping the coil connected to the signal generator circuit. The compass needle will begin to oscillate noticeably. This proves resonance when the applied frequency matches the system natural frequency, representing low-energy hydrogen nuclei from certain body part absorb energy with same resonance frequency and become high-energy nuclei. Lastly, turn off the signal generator circuit and observe the oscillation of the compass needle. It will cause the oscillation to diminish or stop. The decaying oscillations of the needle represents the emitted energy by the hydrogen nuclei was received by the MRI receiver coil.
In conclusion, when the Arduino switched the MOSFET on and off, it will create a varying current through the copper coil and generated a changing magnetic field. This changing magnetic field caused the compass needle to oscillate, and this illustrates the Faraday's law. So in MRI, this simulates how the hydrogen atoms are excited by radio frequency pulse and disturbing the alignment to produce a detectable signal. While when the Arduino signal turns off, it will then cause the compass needle slow down gradually. This happens because the needle's motion will create an opposing magnetic effect that resists stopping, which is explained by the Lenz's law. So in MRI, this can be seen by which hydrogen atoms slowly return to alignment after the radio frequency pulse, and as they relax, they will release the energy that MRI detects to form the images and help the doctor and us to visualize the part of our body. So by understanding these basic electromagnetic ideas through this demonstration help us as biomedical engineers learn how the MRI works and improve the medical technology to help patients in future.